Okay, let's take a second to define what we're going to talk about here in this video. Learning target 5 is finding the inverse of a function, okay? So a function and its inverse. And so we've used this before when we talk about inverse relationships, such as if I'm solving an equation, maybe 2x equals 10, I'm going to use the inverse of 2 multiplied by x. I'm going to divide by 2 because multiplication and division are inverses of each other, as are addition and subtraction. And so just like those relationships, we also have every function has an inverse, something that's exactly the opposite of it. And so the exact definition is that when you have a function, its inverse is the relationship that reverses the independent and dependent variables of a relation. So remember, independent is x and dependent is y. So all of the x and y values are reversed. They're opposite of each other. And if you have two functions and you're trying to verify that they're inverses of each other, what you're going to do is do something called taking the composition, which we're going to talk about here in a bit. The composition of a function and its inverse, if you do that, then you should get x. Okay? So just like when you have, x plus 6 equals 16, and you subtract 6 from each side, all you're left with is x. Same general idea is that when you take the composition of a function and its inverse, you should just get x left. So same idea, and I'll show you what I mean here in a minute. Another important thing to know is that when you're taking the inverse, when you're looking to verify a function and its inverse, if you're looking at the graph, the two graphs should be reflections over the line y equals x, okay? So if I graph that line, this is the line y equals x. If I had, let's say, the parabola y equals x squared, and obviously not perfect graph here, actually let me just pull up Desmos quick to show you what I mean, just because they can make a better graph than I can. So if I graph the line y equals x, that's my line of reflection for any function and its inverse. And then let's say y equals x squared, the parabola. And then its inverse, the opposite of squaring, is taking the square root. So the square root of x, and also remember the negative square root of x. So you can see that the line of reflection is the y equals x line, because those two functions are inverses of each other. Okay? So to find an inverse algebraically, all you need to do is take the equation and swap the x and the y coordinate, or x and y variables. So when my function is y equals 4 minus 3x, I'm going to swap them and have x equals 4 minus 3y. And then remember, when we're doing functions, we always want a y equals to be able to type them into a calculator. So we're going to solve the function for y by taking the opposite of everything that's on the y side. So we have x minus 4 over negative 3 equals y. Typically, we don't like to divide by a negative 3, so what we're going to do is, there's a couple different ways you could write it. You could write it y equals negative x over 3 plus 4/3. Or you could also, if you wanted it in slope-intercept form, maybe negative 1/3 x plus 4/3. Or you could just do, instead of x minus 4 divided by negative 3, you could do 4 minus x divided by a positive 3. That still gives us a positive 4/3 and a negative 1/3 x. Okay? So then, to verify, we're going to take the composite. So what we're going to do is we're going to take what we found that y equals, and we're going to put that into our original function in place of the x. So we're going to put it into the input, and we should just get x left. So we're going to do 4 minus 3 times 4 minus x over 3. Okay? So remember, this minus 3 is like a negative 3. So when I multiply these, I'm going to get something like this because the 3 and the 3 cancel out. So actually I didn't need to worry about the negative part of that because I took care of it here. And then 4 minus 4, remember this minus is going to kind of apply to both parts. So I really will have 4 minus 4 plus x. And then these will equal 0. So I have y equals x. And there we go. I have verified that they are inverses. Same thing on this one. We're going to have, we're going to flip-flop. X equals the square root of 4y plus 3. Solving for y, I'm going to start by subtracting 3. And then to undo a square root, I'm going to square each side. So I'll have x minus 3 squared equals 4y. And then divide by 4. And I'll get y equals x minus 3 squared divided by 4. And then inputting that back into my function, y equals the square root of 4. And then I'm going to put in place of the x, I'm going to put what I got for my original function. So x minus 3 squared over 4 plus 3. So I rewrote my whole function and I put what's highlighted here in green in place of the x. And those 4's cancel, so I'll get y equals the square root of x minus 3 squared plus 3. And remember, when that square and square root, squared and square root are opposites, so they're going to cancel. So we'll have y equals x minus 3 plus 3. Those cancel, and I get y equals x. All right. So for your before class problem, what you're going to do is you're going to look at each pair of functions, and you're going to decide which of the two functions are inverses of each other. So either A, B, or C, or it could be all of the above, and you're going to justify your answer. So kind of using those algebraic steps that I talked about on the verify part, taking those two functions and trying to figure out if those pairs of functions are inverses of each other.